So this question is a diagram question. Any question that has some visual input, I'm going to call a diagram question. I like to just take a look at the diagram before I get started. There's not a lot of information here. I have an XY coordinate plane. I have a graph here. Looks like I have some x-intercepts. I always pay attention to intercepts. I have an intercept there. I have an intercept here. I have a y-intercept here if that's useful. That's pretty much it. It goes on to say the polynomial function f of x with a degree of 4. Okay, that has meaning. A fourth degree polynomial should mean that there are four, excuse me, should mean that there are 4 zeros. 4 zeros would show up as 4 x-intercepts on a graph. We very clearly only have 2 x-intercepts. So something's going on. There's really only 2 things that could be happening here. One is something called multiplicity. So multiplicity is when one of the zeros is counted more than once, right? So again, if this were counted twice and this one was counted twice, that would give us 4. If the first one was counted once and the second one was counted 3 times, like that will give us 4. If we had this is single and that's 3, that will give us 4. So that's what multiplicity means. And I'm not going to really get into how you find multiplicity, but if you've never heard of the term multiplicity when it comes to solving polynomial functions or graphing polynomial functions, please do look into that. The second is real versus imaginary. And this is a bit more obvious when you just think about the meaning of these words. In this graph, we have 2 real zeros, 2 real solutions, 2 places on the graph where I can very clearly see there are x-intercepts. If there were any imaginary solutions, I would not be able to actually see them, right? So in this case, it could be a polynomial function with degree 4, and maybe 2 of these solutions or zeros are real, and the other 2 are imaginary. That's the only way this graph happens, all right? And this is all of the work usually for diagram questions is done through your understanding of the diagram. And that's why I haven't continued to read this yet, because I want to make sure I understand how this degree of 4 relates to what I actually see on the graph. All right, let's actually read the question. Based on the graph, which of the following must be true about the nature of the zeros? Good, so the x-intercepts. So zeros equal x-intercepts. That's just a good thing to remember, to review, to remind yourself of. All right, so choice F. There are 4 imaginary solutions. Absolutely not. If there were 4 imaginary solutions, we would not see the 2 real, very real solutions that we see here on the graph. Choice G. There are 4 unique real solutions. Absolutely not. If there were, we would see 4 x-intercepts, not just 2 x-intercepts. Choice H. There are 2 real solutions and 2 imaginary. That works really well, right? We have the 2 real ones that we see and the 2 imaginary ones that we cannot see. And then choice J, there are 3 unique solutions. I don't know if that's the case. 3 unique solutions and 1 solution. Oh, I see. 3 unique solutions and 1 solution has a multiplicity of 2. Well, that breaks the rule that the fact that this is a degree of 4. If this is a degree of 4, we should have 4 solutions. They don't all have to be unique, by the way, either, though. So, either way, there are not 3 unique solutions here. I don't know what a third solution would be given this graph. So I'm going to say that choice H is the best answer out of these options.